Hi students, welcome to Science Extension and Module 1, the Foundations of Scientific Thinking. This is video number 9 and we're going to be looking at paradigm shifts. The specific learning intention for this video is for you to select one example from the following list to analyse the paradigm shift and how evidence is used to support new theories to explain phenomena and their consequences. And the 4 examples you have to choose from are Lavoisier and oxygen, Einstein and general relativity, Wagner and continental drift leading to plate tectonics, or McClintock and transposable elements, also known as jumping genes. Einstein and general relativity. Back as far as Aristotle, there was the idea that time and space were absolute and the Earth was always at rest. The Earth was the center of the universe and everything basically moved around this quiet, stable body. Galileo and Copernicus noticed some anomalies, both in terms of relative motion that weren't easily described by Ptolemy's epicycles, and then further evidence that was very suggestive of a heliocentric view of the universe that explained a lot of the observations that we saw better than if the Earth was placed at the center. Building on this work was Newton's new paradigm. He removed the separateness from everything and said there are universal principles of motion and forces, and he published this in his Principia, and it contained a huge amount of mathematical justification for a lot of the relationships between moving bodies. He couldn't explain gravity. He could identify gravity as a specific cause of motion, but he couldn't explain where it came from. This was later superseded or improved, if you like, modified. I guess this is a kind of theory modification by Einstein's general theory of relativity, where space and time fuse to form a 4-dimensional continuum. The diagram here shows a little bit of the effect of different masses on the curvature of space-time, and there really does seem to be some impact in the general theory of relativity in this relationship between the movement of light and the interaction of matter. American physicist John Wheeler described this as matter tells space-time how to bend and space-time tells matter how to move.